so 15, we're given the slope field for a differential equation. And we got to find which of these could be the solution to the differential equation with the initial condition y of 0 is 1. So let's review what a slope field is. That's basically just like the values of all the derivatives. So this is like a graph of the derivative. Now, there's always a way to brute force this, like plugging and chugging. But based on the information we're given, we want to just see like what would the equation of this graph be? So let's just calculate the derivatives of each of these. That would probably be the best advice. So let's find what y prime would be here. Negative sine of x. For b, y prime would be negative 2x. For c, y prime would be e to the x. For d, using chain rule, y prime would be 1/2 times 1 minus x squared. So negative 1/2 times 2x. And that'll be x over the square root of 1 x squared. Or negative times negative 2x, so negative x. Then for e, using quotient rule, this would be equal to, I'm messing up here. The bottom function squared. On top, we'll have the derivative of the top, 0 times the bottom function, minus the top times the derivative of the bottom function. Which will then just be, this falls away. This will be just negative 2x over 1 plus x squared all to the second power. Okay, so right away, we know it's not going to be a because this is not the graph of the sine of x. You should know that for sure. So it's not going to be a. It's not going to be b. This graph is not the graph of negative 2x either. You know, it's a linear graph. It's not going to be c either because e to the x is also not this graph. So d and e is pretty much what it would come down to. And some key points you can study is look at when the slope field is 0. And the slope field is 0 here when y is 0. And it's 0 all along this line when x is 0. Now, it doesn't like that won't help really because when you plug in 0, they both give you 0. When you plug in 0 for x, they both give you 0. But looking a little bit more, this part of the graph, the slope fields are positive, or the slopes are positive. On this side, it's negative. So we want to see what would make the graphs positive and negative when x is negative and when x is positive. So let's say we plug in x equals like -1. Let me zoom out a little bit actually. If you plug -1 into this one, you would get a positive. You get a positive number. You would get well, you'll get 1. I'll just say 1 over the square root of 0. And it's not undefined. Like this is an undefined value, or this is infinity. So this wouldn't even work. So D gets eliminated right away, actually. And then by positive elimination, you know it's gonna be E. But let's just plug in 1. If we plug in 1 into this equation, you would get a positive 2 on top over a 1 plus a -1 squared over a 2 squared. You'll get a positive over a positive. So you get a positive number. So that works. And then if you were to plug in a positive number for x, you would get a negative over a positive. So then you can see it works there. So it makes sense. So E would be the answer. All right. (16) if the derivative of x is, if the derivative of f of x is the absolute value of x minus 2, which of these could be the graph of f of x? All right, this is an interesting one. Not really sure what they're trying to get at here, but maybe they're trying to see if you know what happens at 2. So the key thing is to recognize what's the change at when x is 2. What's going on with the derivative? So the graph of this, when x is less than 2, the graph is going to be decreasing. And when f is, no, I'm sorry. It's going to be, it's increasing always. It's increasing always. It's increasing always because the absolute value of any number is positive. So f prime is always increasing. So if f prime is always increasing, that means f is increasing. Or f is you know, f is getting larger and larger. I don't know if I said that wrong. So this is always positive. So yes, the function f is always increasing. It's always getting larger. So let's see which, so it's not going to be 16 because that could see it decreases, then it increases. Not B. Could be, well, it could be D. I'll explain in a minute. Let's get back to that. And it can't be C. So right now it could be D or E because those graphs are always increasing. Now, the issue with this is that it's telling you that the derivative is this function. So it's not telling you there's a point of discontinuity or that there's a gap or like something, you know, undefined. So if you were to plug in 2 here, the derivative of 2 is just 0. So which of these have a horizontal line at 2? It would make sense for E to be the answer. It wouldn't be D because this is not the derivative is not defined at 2. And it's telling us specifically that it's just function and it's not specifying that it's not undefined at any values. So it would have to then be E. Sorry if I made that a little more confusing than I had to. So 17. What's the region? What's the area of the region enclosed by the graphs of f of x equals x minus 2x squared and g of x equals negative 5x? Okay, so for this, you get a graph looking something like this. Negative 5x and this is a parabola that goes downward. So this is f, and this is g. Now, the key thing first is to recognize where they are going to intersect, because that'll let you know the points of integration, where to integrate from. So we set them equal to each other and solve for x. So here we got positive 4x, at 6x minus 2x squared equals 0. Factor out a 2x, you get 2x times 3 minus minus x equals 0. Solving for the zeros, x would be 0, and then x would be 3. So we know we're going to set up our integral. Let me write it down here. Integral, we're going to integrate from 0 to 3. Now, we want to do top function minus bottom function. The function on top is going to be f of x. The function in the bottom will be g of x. And you can solve for it algebraically. You can kind of graph it and, find the vertex and, calculate, what the y values are. But just so you know, every single problem I've seen dealing with a parabola and a linear equation, it's always the parabola would go above it. If it's like this, or if it's the other way, it would be below it. It's really the only way that would make sense for this graph to work, because the g of x graph, you really couldn't draw a parabola that was only below, because it wouldn't be able to intersect again. Anyways, we're looking at this region. So our integral then is f of x minus g of x, or x minus 2x squared minus negative 5x. And we want to solve the key is just to solve now this integral. So negative 2x squared, x minus negative 5x, 6x dx. Integrating, we get negative 2x cubed over 3 plus 6x squared over 2. That's just 3 from 0 to 3. Plugging in 3, 9, 27. That was 3 cancels, so it's really negative 2 times 9. So negative 18 plus 3, 9, 27. Plugging in 0 to both, it just becomes 0. And then this just becomes 9. So the answer is just going to be D.